Welcome to Introducing the Page Server, part of the InfiniteGraph video series. In this video, we will introduce the basic concepts behind the InfiniteGraph Page Server, what it is, and at a high level, what it does. The Advanced Multi-Threaded Server, or AMS, is the InfiniteGraph Data Page Server. You can run AMS on remote data server hosts to make the data files or journal files on those hosts available to the InfiniteGraph applications. AMS is an optional alternative to native file servers such as NFS or Microsoft Windows Network, which means that you can use AMS on any or all remote data server hosts in a distributed InfiniteGraph system. Let's review. Remember that InfiniteGraph uses a federated hierarchical structure to store data on disk. The federation can contain up to 65,535 databases. Databases are actually files on disk. Each database within a federation is specified by a host name and a file name. Within databases, we have containers. A container is a region in the database file. Each container contains pages. In this presentation, we will refer to these pages as pages or storage pages. The pages are where we store our actual data. In order to fully understand the InfiniteGraph Page Server, we need to review the InfiniteGraph component architecture. InfiniteGraph uses two different services as part of its architecture. InfiniteGraph applications use a lock server to manage access to data within the database. InfiniteGraph uses a page server to read and write data storage pages from and to the database. An InfiniteGraph federation can be distributed across multiple hosts. Each data host will need a page server. In a multi-host environment, applications can run anywhere on the network. In this diagram, we have three hosts that are storing data, hosts 1, 2, and 3. They are each running a page server. The lock server is running on host 1. Then we have applications running on hosts 1, 2, and 3, as well as hosts 4 and 5. InfiniteGraph provides what is called a single logical view to all applications that allows each application to see all of the data in the federation regardless of which host it's on. In order to better understand InfiniteGraph, we need to discuss the idea of storage pages. InfiniteGraph stores persistent data on storage pages. A storage page is the minimum unit of file growth. When InfiniteGraph creates a new container in a database or extends an existing container, the space is added as a number of whole storage pages. The storage page is also the minimum unit of physical transfer. When an application reads data from file, one or more storage pages are transferred from the file to the InfiniteGraph session cache. When an application writes data, one or more storage pages are written from the InfiniteGraph session cache to the database file. The application code communicates with the InfiniteGraph libraries. The InfiniteGraph library communicates with the lock server to coordinate locks with the AMS to fetch and store database pages. The working pages of objects are stored in the session cache. The InfiniteGraph libraries provide access to the objects in the session cache, keeping track of pages containing new objects or objects that have been updated. These are called dirty pages and they need to be written back to the database. When an application performs a query, the InfiniteGraph libraries translate the query into a series of page requests to AMS. AMS responds by reading the storage pages from the containers in the database files and sends them back to the application that requested them. When the InfiniteGraph library receives the storage pages, it writes them into the session cache, which is an in-memory storage area. The InfiniteGraph libraries can then extract the objects from the storage pages in the session cache and make them available to the application. The application can create new objects or update existing objects on storage pages in the session cache. The item data is updated on the storage pages. The InfiniteGraph library sends the new and updated storage pages from the cache to AMS. AMS responds by writing the storage pages to the proper database files. When do writes happen? Cache pages are sent to AMS to be written back to their containers in the databases under two circumstances. When a transaction is committed, all dirty pages are sent to the appropriate AMS where they are written into the containers in the databases where they belong. When a new cache page is needed, but the cache is full. In this case, a least recently used policy will dictate which existing cache pages will be sent back to AMS to be written to their database, freeing up space for new incoming pages in the session cache. Pages written to disk during this non-commit write are not visible to other applications until a commit is performed. Managing AMS, starting, stopping, and checking. The three basic commands to manage the page server are obj_start_AMS, obj_stop_AMS, and obj_check_AMS. The start and stop AMS commands must be run from a terminal with administrative privileges. When executed without any other options, the page server host is assumed to be localhost. Each of these commands also has a -help option to get information on available parameters and a -host option to specify which host the command should be run on. For example, if we say obj_check_AMS -host host99, we are saying that we want to run the checkls command against the page server running on host 99. This allows us to start, stop, and check the page server running on a host different from the one that we're currently logged into. Page server command examples. Okay, let's demonstrate running obj_start_AMS. Again, please note that to run obj_start_AMS, you should have administrative privileges. If it's not running, we can start the page server by running obj_start_AMS. If the page server is already running, the start_AMS command will do nothing except tell us that it's already running. In this example, we have not provided a -host option, so we are starting the page server on localhost. We can use obj_check_AMS to see if the page server is running. Here, since AMS is running, the check_AMS command tells us that AMS is running on, followed by the name of the host. If we need to stop the page server, we can run obj_stop_AMS. Like start_AMS, you will need to run stop_AMS with administrative privileges. This will terminate the page server running on localhost by default. You can use the -host option and specify the name of the host where you want the page server stopped. In this example, no -host hostname option was used, so localhost was assumed. When it was run, this command stopped AMS and reported that AMS on host was terminated. This concludes our introduction to the InfiniteGraph Page Server. We've covered a fair amount of material in this presentation, so please refer to the InfiniteGraph Administration Guide for additional information and also for detailed information on each of the commands that have been presented in this video. Thank you.